In programming, there's the concept of modes, or modality, where the program treats user input differently based on the current mode setting for the program. And one of the ways that we can see this idea in action, and many other concepts in programming too, is by how it works in a simple video game. So I'm going to demonstrate an example. This game, which I've written using the Pygame framework, is indeed quite simple. Your job is to press the key that it prompts you to before time runs out. Press the right key and you score a point. Press the wrong key and the game ends, but you can try again. Now, even for a game this simple, we have three distinct modes of operation. There's the opening screen, the gameplay itself, and the game over screen. For each one of these modes, we have separate handling for user input, for drawing to the screen, and for other kinds of internal logic. Now with a game, there's typically an event loop, a block of code that runs in a loop for every frame of the game. And in it, you will process events that are received, like key presses and mouse movements and so on, and from them perform your game logic. But if your game logic is potentially different with each mode, you don't want to try to cram the code for handling each mode's behaviors into the game loop. You want each mode's behaviors to be in its own place. To do this, I've created here a class called, appropriately enough, game, that holds all the relevant data for each game, the score, the timer, and also the game mode. And the mode is going to be a reference to methods in this class. In this case, it starts off as a reference to mode boot. What we do for each iteration of our event loop is we take whatever mode function is set as our current mode and we execute it like this. And in this case, I'm also passing along information about key press events, so that way we don't have to get those events in the mode function itself and duplicate code. Now let's take a look at the mode functions themselves. Mode boot is what we see when we first launch the game. It's just a splash screen, which is created elsewhere, and a prompt to press space to start playing. And if we press space, we execute a separate function that makes the game officially start. And there we set the score to 0, we do some other housekeeping, and most crucially, we set the mode function to mode play. We do all of this stuff, by the way, in a separate function because it's not really part of the mode loop itself. It's something we do once and then exit. From then on, mode play is what gets run on each turn of the event loop. And this contains our main game logic, processing the inputs and making sure that we don't have an end of game condition. And if anything does end our game, we run the end game method, again a one-time function, to display the game over message and to switch modes once again. And then finally, the game over mode just sits there and waits for you to press the spacebar. And once that happens, it starts a new game and it switches us back to mode play. So we're doing three things here. We're using functions, in this case methods in a class, to keep together all the behavior for a given mode. We use other methods to switch from one mode to another so that we can make the one-time changes needed as we move between modes. And we're keeping track of which mode we're in by way of a reference to the current mode's function in our game object. Now again, this is a highly simplified example, but even for a game this simple, you can see how using modes to control how we deal with input and other events makes things easier to reason about. The larger and more complex the program, whether it's a game or otherwise, the more modes it might have, and the more you're going to need an elegant way to handle each of these modes' behaviors discreetly. So that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.